Good day, students. Today I want to solve problems that involve percentage by mass of a compound. We are going to consider trioxonitrate 5 acid. Now, we have to calculate the percentage by mass of nitrogen in trioxonitrate 5 acid. Okay. You must know that the molecular formula of trioxonitrate 5 acid is, how do you know? Tri stands for 3, start with 3, oxo, O, nitrate, N. When you want to know if it is acid, you introduce H. How do you know that it's 5? You should know that hydrogen, the number of hydrogen here is 1. The ion, the cation on it is 1. Hydrogen is written like this: H positive. The ion plus 1 plus N. We are looking for the oxidation state of the N of the nitrogen. Okay, plus 3 times the ion, the anion on top of the oxygen is minus 2 equals to 0. But in case anion is written on top of the oxygen, you introduce it to whatever you see at the numerator, at the power. Is that okay? See, whatever you see at the power here, you put it there. Is that okay? But what you are seeing here is 0 at the power here. That's why you put 0 there. You equate it to 0. Now you have 1 times 1, that's 1 plus N minus 6 equals to 0. 1 minus 6 plus N equals to 0. 1 minus 6 minus 5 plus N equals to 0. Collect light times N equals 0. When you take minus 5 to the other side, become positive, plus 5 equals to 5. Okay? Now, what you need to know is that the 1 mole of HNO3, 1 mole of HNO3 contains 1 mole of hydrogen, 1 mole of nitrogen, and also 3 moles of oxygen. 3 moles of oxygen. And we have to look for the percentage by mass of nitrogen. Okay, 60. How do you get? Let's get the total. The mass of total mass of the compound, HNO3 equals, let's say total mass. Okay, let's say total mass of the compound. Total mass of the compound HNO3 equals hydrogen is 1 plus nitrogen. Hydrogen is 1, nitrogen is 14 plus oxygen, that's 3 times 16. That's 1 plus 14, that's 15, plus 3 times 6, 18. Carry 1, 3 times 1, 3 plus 1, 4. When you add it together, 48 plus 15, that's 63 gram. Still gram. Okay. Now we have to look for percentage by mass of nitrogen. That's a mass of nitrogen here. You can say percentage by mass of nitrogen equals mass of nitrogen over total mass of the compound, which is acid, times 100 over 1. Mass of nitrogen is 14. You can see 14 over the total, which is 63, times 100 over 1. Okay. When you press your calculator, you have 22.2%. Okay. Now let's see other examples. We have to calculate percentage by mass of all the component elements in sodium triazonate. Now let's say total mass of the compound sodium triazonate. Sodium, since this is not an acid, you name the metal first. Sodium triazonate 5, triazonate 5. Sodium triazonate 5 is not an acid. If it's an acid, there will be H, hydrogen at the front. Now how do you know? Sodium is having cation of +1. That's why you now have how many of sodium here? 1 times 1 plus n plus 3 times minus 2 equal to 0. 1 plus n minus 6 equal to 0. 1 plus n, no, 1 minus 1 minus 6 plus n equals to 0. 1 minus 6, that's minus 5, plus n equals to 0. N equals, take minus 5 across equal sign, become 0 plus 5 equals to 5. You see, sodium triazonate 5. Sodium triazonate 5. Okay. Now percentage by mass of all the elements. Now let's know the total mass of the compound. Sodium is 23 plus nitrogen 14 plus 3 times 16. But we have 3 moles of oxygen atom here, 1 mole of nitrogen atom, and 1 mole of sodium atom. Okay. Now we have 23 plus 14. We are having 23 plus 14. 23 plus 14. We are having 37. 37 plus 48. 48 plus 37. That's 585. That's 85 gram. 85 gram per mole. Is that okay? Now, you now have, since we now know, let's know what percentage, perhaps we calculate percentage by mass of all the component elements. Percentage by mass of sodium equals mass of sodium over total mass times 100 over 1. What's mass of sodium? We are having 23 over total mass, which is 85 times 100 over 1. When you press your calculator, you're having 27. Okay, 27%. Percentage by mass, percentage by mass of next element, nitrogen, because mass of nitrogen over total mass. Okay, total mass of the compound, total mass of the compound. And you should know the compound. What's the compound? NaNO3. NaNO3 times 100 over 1, which is nitrogen, you have a 14 over 85 times 100 over 1, which is, when you press your calculator, you have a 16.5%. Last one, percentage by mass of oxygen. By mass of oxygen, because mass of oxygen over total mass of the compound, which is NaNO3 times 100 over 1. What's mass of oxygen? We are having 48, because is 3 times 16 over 85 times 100 over 1. When you press your calculator, you have 56.5%. Now we are considering calculation from equations. From an equation, we can calculate the amount of reactants reacted and products formed. These are important in chemical industries that are engaged in the manufacturing of basic chemicals. Next example, the equation for the formation of water is when hydrogen as gas react with oxygen molecules, hydrogen molecules react with oxygen molecules to give us water. Is that okay? It's liquid. Now let's now balance it. Hydrogen you can see that it's not balanced. We have one molecules of water here, that's two atoms of oxygen. We have one atom of oxygen. Okay, two atoms of hydrogen, that is one molecules of hydrogen, that's two atoms of hydrogen, two atoms of oxygen. Here we have two atoms of hydrogen, which is the same with this, but oxygen, we have one atom of oxygen here. Here, this is the product. This water is the product. These are the reactants. At the product side, we have one atom of oxygen. But what we need to do is to balance. Now, if you put two here, let's balance this side first. Since you're having two atoms of oxygen here, you put two here to balance the oxygen. That's how to balance equation. You'll be given wrong equation, you are the one to add the necessary number of molecules to balance either side. Is that okay? Okay, now let's see. We have added 2 to this water. It has made oxygen to be balanced, but as you are balancing the oxygen, more problem has been created to the reactant side. Now you have balanced the oxygen, the hydrogen is not more balanced. What you need to do is that you now see how many hydrogens here is 4. Try to add 2 to this hydrogen. Is that okay? Now, let's now see the equation. 4 hydrogen, 2 oxygen. These 2 that is at the front is affecting this oxygen likewise. That means that they are both balanced. Okay, you now have to calculate the number of moles of oxygen required to yield 6 molecules of water. Okay, you can see one molecule of this is one here. 1 molecule of oxygen yield how many molecules of water? 2 molecules of water. You can see it. 2 molecules of water. Now 6 molecules. How many molecules of oxygen now? Because that's the number of molecules of oxygen. X molecule of oxygen yield how many molecules? You have to yield 6 molecules, 6 moles of water, H2O. Let's now see. We cross it. That's x, 2 times x. We cross it like this. 2 times x equals 6 times 1. 6 times 1. Is that okay? Divide both sides by 2. Divide by 2. 2 cancel 2. 2 here 1. 2 here 3. That's 3 molecules. X molecule equals to 3. Equals to 3 moles. 3 moles. Okay? So therefore, the number of moles, the number of moles of oxygen required to yield 6 moles of water is 3 moles. Okay, let's see other example. Make sure you balance your equation before you start solving the problem. You can see that we're able to add 2 here. That's why we know 1 mole of oxygen will yield 2 mole of water. Now, X mole of oxygen yields how many? How many moles of oxygen will yield the 6 moles of water? From there, just cross it. 2 times X equals 1 times 6. When you get it, X equals 3 moles. Now say the number of moles of oxygen required to yield 6 moles of water is 3 moles. Let's see another example. This example 1. Now, what is the mass of oxygen needed to burn 4.6 grams of sodium? You can see sodium combines with oxygen as follows. You can see that sodium, 1 mole of sodium react with 1 mole of oxygen to give us 1 mole of sodium 1 oxide. How do you know that? You can see, let's see, sodium. How do you know it's sodium 1 oxide? We have 2 sodium. I told you. Okay, I told you that sodium is 2 times ion of sodium is positive 1. That's 2 times 1 plus 1 times ion on oxygen is minus 2, which is equal to 0 because nothing is at the power. That's 2 plus, sorry, 2 times, this one will be 2x. Let's call it 2Na because there is no one again at the middle. We call it 2Na, which is 2Na plus minus 2 equals to 0. 2Na, collect the light times 0 plus 2. 2Na equals to 2. Divide both sides by 2. Na equals 1. That is sodium 1 oxide. Okay, now what we need to do is that we need to balance this equation. You can see that we have 1 here, 1 mole of sodium. We have 1 atom of sodium and 2 atoms of sodium here, and we need to balance it. Okay, how do we do that? You see that you're having 2 atoms of oxygen here. We're having 1 atom of oxygen here. What you need to do is to balance it so that you're having, if you want to balance this one first, let's balance the one that is lesser first. At the product side, this is 1. Let's make this one to be 2 because oxygen is 2. In the course of balancing this oxygen, you have created another problem for the sodium. Okay, but it's a problem that can be solved. Now you're having 4 atoms of sodium. What you need to do is to add 4 here. In the course of adding it, It's now balanced. You can see it. 4 atoms, that's 4 atoms of sodium, 4 atoms of sodium, 2 atoms of oxygen, 2 atoms of oxygen. Now, and I ask, what is the mass of oxygen there to bond 4.6 gram of sodium? Okay. Now, 4 moles of sodium atom four moles of sodium reacts with how many gram of oxygen? You can see it. We have 16 times 2. Oxygen is 16. Oxygen is 16. Is that okay? Sodium is 23. That's 16 oxygen. That's 16 times 2, which is 32. 4 moles of sodium react with 32 gram of oxygen. Okay, 2 gram of oxygen. Now, okay, mass of, now let's say 4 moles of sodium, and let's get the moles of reaction of which. Let's write it like this: 4 moles of sodium reacts with 1 mole of oxygen. Is that okay? 4 moles of sodium react with 1 mole. You can see 4:1. Now let's see the mass of 1 mole of oxygen. Mass of 1 mole of oxygen is 16 times 2, which is 32 gram. Okay, mass of 4 moles of oxygen of sodium. Mass of 4 moles of sodium equals 4 times 23. When you get that one, you have, when you press your calculator, you have 92 gram. Okay, now say 92 gram of sodium reacts with 32 gram of oxygen. You can see it that 92 gram, when you multiply 4 times sodium, the mass of sodium is 23. 4 times, you can see we have 4. The sodium is 23 times 4, and is the one that react with oxygen. You know, but the first thing you need to do is just try to write the expression 4 moles of sodium react with 1 mole of oxygen, because there's 1 here, and that's a mass of 1 mole of oxygen. 1 mole of oxygen is 0.02. Now say 16. The mass of 1 oxygen is 16. You have 2 of them times 2. You have 32 gram. You have to look at your reaction, equation of reaction, and the mass of 4 moles. Why do we write mass of 4 moles of sodium? You have to look for what is the mass of oxygen needed to burn 4.6 gram of sodium. That's why we need to get the moles After getting the moles, we now multiply the moles with the mass. That's why you have 4 times 23 to give you 92 gram. Now I have 92 gram of sodium react with 32 gram of oxygen. Is that okay? You see that the moles is very important. If you don't balance the equation, there's no way you will know the number of moles you will use to multiply the mass. Is that okay? Let me repeat the statement. 92 gram. How do you get 92? 4 times 23. That's 92 gram. 92 gram of sodium. 92 gram of sodium reacts with 92 gram of sodium reacts with 32 gram of oxygen. We got it by saying 16 times 2. Is that okay? Now, we now have 4.6 gram of sodium reacts with what? X gram of oxygen. Okay? When you get that, you cross multiply. Now say 92 times x gram equals 92 times x gram equals 4.6 times 32. Divide both sides by 92. Divide by 92. 92 cancel 92. X gram equals, when you press your calculator, you have 1.6 gram of oxygen. Okay, this is the mass of oxygen needed to burn 4.6 gram of sodium. This is the end of our class. Please subscribe to my channel so that you can have access to the latest video. Have a wonderful day.